Good evening, everyone, for the last session. It's my pleasure to present Wenjing, and he is talking about introducing decentralized identity to Matrix. The stage is yours.
All right, audio's on, thank you. Well, thanks for sticking around for the last session of the day. So my name is Wenjing Chu. I'm a Senior Director on Technology in FutureWay, and maybe I'll use this as a part of the introduction for myself, but also my talk as well. So being contributing to many different organizations, and earlier, if you are with Quantum and Sumner earlier as well this afternoon, I think you learned quite a bit about authentication. And definitely the OIDC talk is a really nice setting for me. So, so I work for several organizations very similar to OpenID. One of them is called Open Wallet. The other one is called Trust over IP. Many of you may know about W3C. And there are other related communities, such as OpenID Foundation, as well as digital identity organizations in Europe. I don't know how many of you know about EU's digital identity initiative, or there's a law called EIDAS. Oh, okay. So I hear people nodding. In Germany, there's a Spring D is actually doing implementation or prototype implementation right now for European-wide digital ID wallets, etc. So I'm going to generally talk about that area. I'm intentionally keep my slides non-technical, because each one of them may take way too long for us to really explore properly. But I want to introduce the idea of decentralization. Okay, so I have three things to cover. The first is just talk about why do we need a decentralized identity, especially for Matrix, and what does that really mean for users and also for the entire ecosystem. The second is about a new way of doing that, and being personally working on a protocol called trust spanning protocol, and so that would the goal is trying to realize some kind of a universal interoperability of authenticity and privacy. And then finally, maybe seeking feedback and what's the good approach to introduce decentralized identity in Matrix. I'm a complete newbie on Matrix, so I ask your forgiveness ahead of time if I'm not very knowledgeable about that. So as a newbie, I just sort of started from the Matrix manifesto. What we want to do, right? We talk about secure, we want to interoperable, very good ideas. And there's this word decentralized. What does that mean? Decentralized communication. And then the manifesto itself talks about people should not be kept in a silo. We should have our privacy, and that's very basic human right. Unencumbered, for example, like portability, going from one server to another, carry your personal information with you, things like that, right? So those are the goals I think I want to focus on this talk. And my main goal is really trying to explain the concept, and I try to make it not as radical, but I hope when you come to the end of the talk, you will realize it's a very radical idea. So in very high level, most people, when they speak about identity systems, they use three keywords: centralized, federated, and decentralized. Okay, so a centralized system, it's a very simple client server. You, as a user, you create an account, and the server is really your service provider. So the server takes care of you, and you are really a guest in the system, right? And the server authenticates you, make sure it is actually you, and the server then takes care of your private data with some kind of contract, whether it's legal or social, to not to betray your trust in the system. A federal system, I think it may just getting closer to that, is you have multiple of these servers, and they have some kind of exchange protocol between them. And so therefore, the users can be on 2 different servers and still be able to talk to each other by some kind of agreement. So I think Germany is a federated system, so you could have identities or ID cards, for example, issued in one place and used elsewhere. And that's definitely the case in the United States, where you have these driver licenses issued by a state, and if you go across the boundary to another place, you are a guest there, right? You don't have exactly the same right as the native residents there. So that will be a federation. Federation naturally requires some kind of agreement. What is the minimum requirement that need to be? So those identities need to sort of conform to that. A decentralized system, then, it goes one step further, which is basically saying that the identity is actually issued or created by the user themselves. Okay, so how does that work? How can we make that secure and preserving privacy? Why it is needed? And that's we're trying to cover here. So this would be very difficult to argue right now, but maybe by end of this talk, we can come back on this. But I want to maybe ask a couple of questions, see if we feel the same way. The first of all, how many of us think that today's internet is secure and private? Right, exactly, right. And how many of us feel like that the solutions that we are talking about are dramatically different or different enough so that we can be designing systems that will be better? Are we on, the question I really want to pose is, do you feel like we are on the right track? Or maybe put a more harsh way would it be like, do you think a matrix is secure and private? And I think we want to ask ourselves that question, and maybe then from there to dive down to like, what do you really mean, right? And maybe get a more a deeper answer on these questions. So in very high level, I'm making a sort of very general statement that centralized systems are secure only if you are in that slot, if you accept that particular arrangement for you, right? And also the server or the central authority take care of you in good faith, right? And that's, so I would say yes and no, depends on really where you are. Interoperable? Probably not. Private? Not really, not to the server, right? And do you have a choice? Probably not. Very difficult. And the reach, I think it's mean like, can you talk to anybody universally? I think I would say no. Like if you are in Apple's system, you may be able to talk to all the other Apple customers, but will be very difficult to go beyond that. And so those are the known issues. And the federal systems, you can see that solve some of the problems, but I don't believe that we really go far enough. And also federal systems keep, create this new dynamic where the bigger state decides in a way. Okay, so if you have a federation and there's one of them very mature and big, you will naturally will have to go with that, because if like in US, if California decides a particular standard, usually that becomes a national standard, because no business will be able to live without that state being in their market, right? So similar dynamic will happen here as well, that if we have a federation system, then really, it takes a lot of work, but doesn't automatically solve all the problem for you. So I hope that set up the need, sort of like why I want to explore different kind of identity system. And again, as a new user, I start to reading matrix, and this would, you'll be very familiar with like how this overall system works. And this is a classic federation system. You have servers and clients, and between the servers, you have some kind of agreement how they can do operate, and within those boundaries, user A from server A can talk to user B on server B, right? And room is the sort of the structure that these conversations happen. And so luckily, Quentin's just before me, so he talked about the mass server for OIDC or OpenID based authentication. And this picture essentially says that a client can request for authentication that is provided by a server. The server really talks to the actual, they call OpenID provider. So this could be any third party. And the most common of those would be things like your email provider, right? Or if it's an Apple customer, it will be Apple. So naturally, this is a very generic interface. Is good in the sense that the provider and the server doesn't have to be the same entity, right? So those are the providers that give you the flexibility that is not tied to a particular server. And so I probably want to stay in this slide a little bit longer so that we get into the difference of a federated and decentralized identity system. I want to maybe ask like how many of people in the room know about the difference between an identity or ID, identifier, and a credential? Like, would that be too much? Okay, so I'm going to use roughly the term a identifier purely as a string, right? It's something that it may be very long, may be complicated, but it's basically some handle, right? While a credential is some agreed upon data format, again, that the receiver of that information can verify. So you would, for instance, like your university degree is a credential that you can hand that over to another party, and they would believe you because they think they can verify it. With, so that would be the main difference here. And so what we're really talking about authentication is the process where a user or a client provides some information, or we call ID, to a provider. The provider does what it needs to do, which is talking to some kind of back-end supporting system to do verification. And that result, right, is usually like in OpenID, it will be some kind of token. And that result is then communicated to the home server, and home server say, oh, he verified for me, right? So all I need to do is hold on to this token, and I'm going to assume this user is authenticated, right? Okay. So that particular scheme works really well, and the question really is that who then issues this particular ID? Like if this particular ID is the Apples or the Googles of the world, then you have a problem because you would be essentially leaving all your activity known to that particular provider. Okay, every time you log in, it's a known event, right? So they will be able to track you, and a lot of times, like if you do payments, travels, taking a bus, all that event data is captured somewhere. The authenticator will have to know about that, right? And so those are very sort of private information for all of us, and this is happening in background. And so if the concentration of such information is really in large scale, and every time you use your phone, that is a huge concern. And so we're talking about similar kind of arrangement in terms of like what kind of software is around, but we want to see if we can produce this identifier in a decentralized way. And so we create this identifier so that the provider would be able to do the authentication without notifying the essential essential authority, right? So, for instance, like Germany is working on the Europeans' digital ID, and currently there are quite a few of experimental implementations being actually, developed right now. I think later this year they will be doing testing, etc. And one of the requirements is basically to have a high privacy. That's allowing that the authentication happen without the issuer keeping track of it. So the easiest way what we can think about that is that today in analog world we are issued a identity card, and you use the card if it's not digital, right? You use the card with another maybe store to present my identity, and the checking are happening between you two, without telling the issue government office like this is happening. And that's not the case for our typical federated digital ID. And that's a huge problem, right? So decentralization just trying to solve this problem in a way that is much more secure and also privacy preserving. So, so hopefully this will be very familiar to you now. This new diagram is starting to evolve. So this is, I think, is essentially the same. But we introduced a new concept of a wallet. And therefore, the wallet, what is that? It is, we've been talking about a lot of keys earlier in the session, right? You need to keep track of a whole bunch of private keys and many keys actually in your client, and it's not easy to keep information secure and very safe. So naturally, the time will come that we have so much private information we want to guard against fraud and other kind of hacking, and we will need a more well-defined entity, which we will call a wallet. Essentially, you can think about these private keys and stuff, credentials, as well as these very important and private information, and they would be kept in a uniform, well-defined data structure or an entity that we call wallet. And we already have many of these around, actually. So our smartphones all have wallet in it already. And when I go to airport, I put my boarding pass in the wallet. And so this is the same concept. It just showing up in the consumer interface. It may look like one thing, but we want to more generalize it, so such a software entity can holding this information. And the wallet also can implement then maybe biometric or other kind of UI in order for us to verification or tie that to a natural person. And this is also very important because we want to make sure we have a way to really distinguish a real person versus for example, AI simulation. And that's very practical today. And so these are the ways that we would need to really think about authentication as a solution. So this allows us to really think about client as two pieces, and the wallet piece can be standalone, can be embedded in your client as well, right? And so I'm listing a lot of names here. I wouldn't have much time to really explain to it, but I was chatting with someone earlier today about Germany's health system, and they would like to be able to use Matrix as a software to maybe be the messaging between a doctor and patient, and that would require a lot of health-related credentials or private data. And so the guarding of those data requires us to be very careful on how this is done. And so we want to do it in a way that is very strong. So similarly, if any kind of financials, passports, driver license, all fall into this category. So I've listed a bunch of standards that have been, different organizations who have been defining the technical specifications on how this can be done. I've be happy later. We have a free time to go a little further, but I just want to point that out here. With the rest of it, I think the main new thing I want to point out is that when we do then authentication and talking to the home server, there will be a lot of requirement to minimize disclosure and also compliance. So the laws would require us, for example, to minimize the information necessary to complete the authentication required. Now, matrix, if simply doing text messaging, of course, maybe what you need is not very much. But if I build a healthcare application using matrix, now that authentication need to be stronger. If I want my healthcare app also be able to do payment, for example, and my requirement goes up again, right? So authentication is never a single shot thing. It's a different degree of authentication we need to do depending on the activity the user is engaged in and your actual app. So I just want to use this picture to show that overall this process will define different degrees of authentication, and they may be needed for additional credentials, for example, when we start to engage in higher value or more critical applications. Okay, so. So hopefully that gives you some sense of what the, supporting decentralized identity mean, and it will be one thing to remember would be much more user centric, because it's going to be related to you rather than related to which server. And the second part, how am I doing time-wise? Okay. Okay. So the second part of this would be one way to do it. Now, this is not the only way, but we've been working on a trust spanning protocol, and this is a terminology we use to identify the minimum requirement necessary in order to achieve this with one single protocol that can produce what I call universal interoperability. So this system or trust spanning protocol essentially deals with IDs as if it's an address. So you will identify, the two party, Alice and Bob. You will have two identities or two strings of addressing, and then they start with nothing and with zero trust, and they need to establish some kind of trust. And essentially, we want to do is to have the public and private key pairs to be verified in some way, and also tie that into a real person if the endpoint is a natural person. And we may also need to check the person's credentials, right? So if you are going into a government office, they may want to check that you are an employee here, you are allowed to join, for example. And so this is, again, very different from simply I log in, I'm in, or I'm not in. That's a binary decision. This is a much more complicated decision process, right? And so these identifiers and the exchange of information they need in order to verify each other is very interesting. I think the previous talk on both on cryptography as well as, and later on, I think we mentioned the MLS as well, have very related concepts and technical problems to solve. So I won't go into it, but the backend technology or algorithms involved are very similar. So we're talking about public key cryptography. I want to see two things that the trust spanning protocol want to achieve, and those are really the two very important things. One is authenticity, and the other is privacy. And you will see that I use quite different terminology here. So I don't call it secure and encryption or that. We want to say authenticity, basically trying to say who says what. And so who part it will be identity. The what part I think we call integrity or messaging integrity. And so so signature, for example, is one way to achieve that. Privacy really comes to also two categories, at least. One is confidentiality, which is really keep the message into the secret between the parties in the exchange. That will be encryption. The second part is metadata privacy, which is really whether some party can or a third party can track you on the activity. So, so we use a room. People may not be able to hear what's being spoken inside the room, but they may be able to observe who entered the room and who left the room, right? So those are metadata privacy. And so those are the, I think, the main things when we talk about the trust is so that I can be certain who's in the room, who's known, who can observe what. And so those are the conditions I think creates a certain type of trust when we create such a room. So that's probably as much as I would go into in technical detail. If you are interested, there is a spec and there's a REST implementation code as well. I would just keep it for your reference. So I can go on to the next one, which is talking about the interoperability and how do we do this. So I'm going to go relatively quick. So we talk about user-centric kind of the identity. So most of the time when we have logins, etc., it is the server, right? It's the main point of the system. The server knows a lot and authenticates the user. We rarely do the other way around. Yeah. Okay. So, but the user-centric really says A and B are in peer-to-peer relationship, and they need to really authenticate each other, which will really be, I think, very important for the fraud, for example, is a big problem today. And in content world, that the fake media or fake pictures are also a big problem, and none of these problems can be solved with only one-site authentication. So we really need to, I think, invest into infrastructure, allow us to do peer-to-peer authentication. So that's going to create much stronger authenticity. The authenticity level can be strong enough, not just for messaging, but for, like I said, healthcare, payment, legal, signing documents, entering a new country, all of that, right? So it's much stronger, and how strong this goes will be depend on the application and the context you're in. Second one is it has a much stronger privacy, and this is not only talking about data minimization, as in what to disclose. So one common usage is called selective disclosure. If you have a document, how do you issue or use a partial information in it? Zero knowledge proof would give you ways that that you can prove the qualification of a user without disclosing the actual source information itself. I mentioned about metadata privacy to reduce tracking and correlations. So this is very common, I think, in the internet. And if we don't fundamentally change the ID system, we will never be able to avoid this. And of course, there's we've talked quite a bit about end-to-end encryption already, but there's another part of it called non-repudiation. Can we be able to identify who said what after the fact as well? And so those are the very important in different applications, not for every application, but some are very important. So, so overall, these will enrich much richer application and make Matrix a very general purpose platform for better and open next-gen internet applications. the final portion I want to talk about is really how to introduce such a ID system. And again, I simply scratched a very high level, many things, many terms, but I want to see like maybe link to something that we can tangibly do, right? And so I did a little bit of search, and these are the examples that come up with. Some of them are really old, but these are great ideas and things that I think a decentralized ID would be able to support. And the first one talks about decentralized identity itself. The second one is about non-interactive account verification. So you just listened to earlier on how OpenID or IDC works, right? And so I think the analogy of a user onboarding would be relatively simple because you already have some kind of ID in your wallet. And now you have a Matrix app. If you're a new user you want to start, all you need is pick which ID to use, and you're done. And so the rest of it really doesn't require anything from you. It will be a single key onboarding. It's extremely simple to do. If now you are ready to do, actually do let's say a payment transaction, which maybe the store wants you to show an ID. Usually in US, I use the example of buying alcohol, which they want you show that you are 21. And even with all my white hair, they still ask me. And so this was also a one key, one button interaction for the user to do. So those are very non-interactive verifications. The third one I picked up is about portable accounts. So this really comes down to sort of in a federation model. In theory, you can move from one server to another. But it's there's a lot of baggage you need to move, right? Which data belong to you? What is and besides you move over, you have two separate IDs. They are not compatible, right? And of course, hopefully the decentralization of identity and also user-centric way of doing that allow us to actually carry our private data with us, right? And it will be much easier to do. And that's just only scratching the surface of many of the great ideas I think already documented in many of these issues. All right, so this is, I think, my last slide. And I basically pose a question to Matrix community as really a new person who really don't know too much. Is that a good idea to do such a thing for Matrix users as well as for the ecosystem? And if we have interest in such a system in the long term, then what is the right way to approach this? We know that even OIDC itself, it's very new, right? It's not fully deployed yet. And now I'm talking about, even newer systems that some of the spec are still being developed. But I do see that this may be coming. The European Union, again, and Germany have committed to produce a universal digital ID in 3 years. I think this is the first year, so we are already 1 year over. There's 2 more years to go. So I would say that many of these technical solutions are actually quite mature, and so these capabilities exist. And I think the question is whether we want to jump. Are we, ready to really say, that's the kind of a decentralized application or matrix I want to see, and whether that will be the future, right? There's people talking about these so-called killer apps, because once you have a strong identity, you can do a lot more than just text messages or video calls, or right? You can do quite a lot. This application can be anything you want it to be, actually. So the people use the word super apps for it, right? It would also solve problems like AI content authenticity. So I don't know if everyone familiar with that. There's another organization called C2PA, which is really signing the pictures a software generates. And so in this case, you can say OpenAI generated this particular picture, so that the user can verify that this picture is not a real photograph; it's a computed image, right? there's a lot of standards. EUDI, I mentioned multiple times. In the United States, they use MDL or MDoc for mobile driver license. That's being used today in the airports where you can use the digital driver license for boarding airplanes. Verifiable credentials is a huge interest in and currently being actively worked on in W3C. So that will be a standard that is applicable to any of the web. We've been also just starting this week actually working on a web-based decentralized identifier. That's another of W3C standard on we call this. So this will allow a URL to be verifiable so that you can use that string as a identity and it solved problems like key rotation. I think I was earlier session had a question about that. If you rotate the key and you are in the middle of the transition, what happens? All those issues, as well as if you accidentally lost the key, how do you recover it, right? And how do you maintain a long-term identity? So these are not one-time tokens, but you actually keep this string as your identity over many, many years. So maintenance and management of those are quite critical. Once those ID systems are built and deployed, then I think we could think about how can we then make Matrix clients and Matrix ecosystem much more powerful, because you can do so much more than just messaging, and also much more, I think, privacy preserving. It will be also more convenient, easier. Your onboarding process will definitely be a lot easier. Maybe potentially be able to move around, picking your favorite server as well. And so those will be I think, some of the benefits. So I'm here to seeking sort of a feedback and see if you have any questions or suggestions and how we can approach this.
Very much, Wenjing. And I see the first question.
Thank you for your talk. So over a decade ago, there was a social network that was already federated and already had nomadic identity. I don't know who here knows about it. It was called Red Matrix for a while, then it became Hubzilla. But they talked about, the creator called it the Zot protocol. But there's actually already, and it's, it was live in the wild with people using it, and they may still be using it as far as I know. But there may be lessons to learn from that. So I would recommend people investigate that. There's like actual code run by people. And the coolest thing was he had the same idea that you should, the individual needs to own their identity. And so even though you might start an account on a server, you basically have the private key. Right. And the protocol, which is maybe, it could be a model for what Matrix should pursue, was that when you could get other accounts on other servers that were independent, but you would bootstrap it with that same identity. And then you'd have, those would become clones, and the inter-server communication would funnel any messages to your identity to whatever home servers you had clones on. So in a lot of ways, it was already implementing this just in maybe a different software framework. I think it was PHP. But that's what I would like to point out to people, that there is a model that you could at least look at. Yeah, and there's also a community called Rebooting Web. I don't know if you guys heard about it, but basically this is really an old problem, and it's very difficult to solve. But the basic idea is around, this is just that the new, I think, algorithms and protocols get more mature now. And then we also have these government initiatives to create such identity, because that's very costly, right, to create and maintain such identity. But if the government spend the resources to create such one and offer to every one of us, then I think we can use that identity to manage our keys. And we'll make that much more simpler to manage the keys properly, and also be able to then enable much higher value transactions. I don't know what's the right way to put it, but then you can do more serious stuff in the same app, right? Yeah.
Great. I have a few concerns with decentralized identities, the general concept of the private key sitting on the client, primarily around, you have similar decentralized systems which do this, things like Bitcoin and stuff. If you lose your password for your wallet, again, there's no centralized system to really recover these. There are protocols that's designed to try to, give parts of the private key to different friends who you trust, and you build a web of trust and all this other stuff. But in general, in the real world, sometimes you do need to have a centralized system to recover because in practice, people are people, right? Like the real world is very messy. And likewise, Matrix is used by schools and governments and militaries and stuff like that. And they absolutely want to control their users, right? Like they don't want to give them the power to leak information or identities to other services. And tying like non-repudiation to if you have your core identity, which is then you derive other keys, which you then use in other services, that surely also leaves a trail of, that you're using all these other services. And you have another form of metadata that you're leaking. So I think, I like the idea, but whenever I've looked at this, I see you're leaking other things and you're just increasing the overall complexity of the system.
Yeah, you mentioned quite a few things. I don't know whether I can cover all of them.
Sure.
But there's a question about comparison to a Bitcoin account and right, which I think is quite different. The problem with that, of course, is that they give you a key, and like for example, in Signal, you have that issue too. They give you a key, and there's no way to recover if you lose it, right? In this case, these identities or the credentials are actually not unrecoverable. So they are basically the secret is associated with you. You are managing it, but it's not on your device alone. So one way to do it would be that just like you go to a government office to issue an ID, if you lose it, you can still go get it back. Right. And because it's based on your personhood. I don't know, it's a vague word, but it's based on that information. So you could essentially use that, and I think the key to answer all these questions is this identity we call wallet, because this is a very complicated, sophisticated application, really built, with quite a work in order to make this easy. I think the key is that once you've done that, you don't want to just throw it away for one application. You want to make that reusable, right? So if some government or other organization have built this facility already, infrastructure, we should be able to reuse that for Matrix. And so again, I could easily use my data about my driver license in California and use that to key up another key, and that will be my identity. I don't disclose any information, but then I don't have to arbitrarily manage this. Because if I lose it, I can always go trace it back to a identity or some entry in the database, eventually recover it. So hopefully that point to the solution. I know we have no time to dive deeper, but this is the kind of idea we talk about here. And there are commercial, real applications, of course. Both almost any of the mobile phone vendors have produced wallets already, and the wallet user experience is in a way the kind of thing to come, I think. And so that allows us to have both ways. We can recover, and the IDs are very strong, and most of the time sits on your device, but it's clearly backed up somewhere. Now, the person who backed up for you don't have the keys. So your information is not leaked to them, but you can recover because you are a real person. You can always show up somewhere to recover.
Okay.
That makes sense? Okay.
Yeah. Thank you.
Okay, thanks a lot. Another question? Okay, that's it for today, and we also running out of time, I fear. It was a pleasure to have you with us on T2, and thanks a lot for the proposition.
Thank you very much.